In organic chemistry, distinguishing between different classes of amines is a fundamental skill. Today, we focus on the carbylamine reaction, a powerful diagnostic test used specifically to identify primary amines through a unique chemical transformation. The carbylamine reaction is famous for producing an unmistakable, foul-smelling substance called an isocyanide. This intense odor serves as a definitive sensory indicator that a primary amine was present in the original sample. To perform this test, we react a primary amine with chloroform and alcoholic potassium hydroxide. These reagents work together to convert the amine functional group into the highly reactive and pungent carbylamine group. Looking at the balanced equation, 1 molecule of primary amine reacts with chloroform and 3 molecules of base. The nitrogen from the amine bonds with a carbon atom to form the Republican North Carolina functional group. It is critical to remember that only primary amines undergo this reaction. Secondary and tertiary amines lack the necessary hydrogen atoms on the nitrogen to form the triple bond required for isocyanide production. The reaction mechanism begins with the formation of a highly reactive intermediate called dichlorocarbene. This electron-deficient species is generated when the base removes a proton and a chloride ion from the chloroform. Once the dichlorocarbene is formed, the nitrogen atom of the primary amine acts as a nucleophile. It attacks the carbene, initiating a series of elimination steps that eventually remove all chlorine atoms. After the loss of 3 hydrogen atoms and 3 chloride ions, we are left with the carbylamine structure. The carbon and nitrogen are joined by a triple bond, creating the characteristic foul-smelling product. Let's apply this to an aromatic amine like aniline. When aniline is heated with our reagents, it transforms into phenyl isocyanide. This reaction confirms that aniline is indeed a primary aromatic amine. Even simple aliphatic amines like methylamine react vigorously. The resulting methyl isocyanide is extremely volatile and possesses the same characteristic offensive odor used for identification in the lab. If we attempt this with a secondary amine like dimethylamine, no reaction occurs. Because the nitrogen only has 1 hydrogen, it cannot complete the elimination steps required to form the carbylamine group. Similarly, tertiary amines are completely inert in this test. With no hydrogens attached to the nitrogen atom, they cannot form the intermediate stages, leaving the solution without any change in odor. Safety is paramount. Isocyanides are toxic and their smell is persistent. This reaction must always be performed in a well-ventilated fume hood, and products should be neutralized with dilute hydrochloric acid. To summarize, the carbylamine reaction is a specific test for primary amines. Primary amines produce a foul-smelling isocyanide when heated with chloroform and base, while secondary and tertiary amines do not. Remember the key components: the reagents are chloroform and alcoholic KOH, the reactive intermediate is dichlorocarbene, and the final product is a carbylamine, which signals a positive result. Test your knowledge: which of these would produce a foul smell? The answer is A, ethylamine, because it is the only primary amine in the list. Diethylamine and triethylamine are secondary and tertiary. Understanding these diagnostic tests is essential for identifying unknown organic compounds. You are now equipped to explain the carbylamine reaction. Thank you for watching. Generated by Vision Solve AI.